Weathering and erosion, the great topic in geography. There is water erosion, there is wind erosion, there is acid erosion, there is slow landmass movement, there is fast landmass movement, and of course, there are glaciers. What are those huge masses of ice and snow, and what role do they play in weathering and erosion? Let's find out. Hello, my name is Enzu and I am your host for this new episode of Weathering and Erosion. For this episode, I have created 3 models describing glaciers and how they work. How do they break rocks and how do they shape the land around us? Now, weathering and erosion are very important and different terms in geography, but they are also at the same time used interchangeably. So, to start, I would like to clarify what these 2 terms mean before going to the fun stuff. Weathering, put in simple words, is basically the breaking down of rocks. There are 2 big types of weathering: chemical weathering and physical weathering. The chemical one is the most obvious type of weathering, and you can easily notice it because it can happen literally overnight. Ew. Physical weathering, also called mechanical weathering, mainly occurs with water, ice, and glaciers as the weathering agent. The demonstration I will present will be about glaciers and how they help Mother Nature clean the surface of our planet. Before I show you my models, I would like to briefly go into glaciers and explain what they are and how they work. Glaciers are huge and dense masses of ice that are constantly moving. These usually form when snow starts accumulating in a valley for a very long period of time. The process of forming a glacier can usually take multiple centuries. Global warming, which is the warming of the Earth's climate, is slowly destroying these majestic glaciers by slowly melting the ice that composes it. Boo, global warming. Glaciers are very important to nature as a whole because they have the ability to literally move tons and tons of rocks and debris by scraping the surface of lands and valleys. Glaciers are often considered as the bulldozers of nature. These masses of ice are responsible for the formation of fjords, cirques, and moraines. It was glaciers that literally carved out the Great Lakes of America about 22,000 years ago, during an ice age in which the glaciers from the north reached the areas of southern Ontario. To think about what these beasts can do is mind-blowing. There are 2 types of glaciers: continental and valley glaciers. There are only 2 continental glaciers on this planet, and they are located in Greenland and Antarctica. Valley glaciers, however, are much more common. They occur in valleys and in fjords, all over the world. Now, enough about glaciers, let's get on to the models. Please note that the making of these models took tremendous effort and time. Through many trials and error, at the cost of filaments and cardboard, I finally made the perfect models. Here they are, the models of Rumbug Glacier, with larger cross-sections made out of cardboard. This 3D model is obtained from Google Maps, and it is exactly what the Rumbug Glacier looks like. The real thing is exactly 10,000 times this size. Now, just to give you a bit of background here, the Rumbug Glacier, Hongbu Bingshan in Chinese, is a very famous valley glacier located in the Himalayas. The glacier receives its snow and ice from the highest mountain of the world, which is Mount Everest, located here. The glacier has been very important in the formation of the valleys next to Mount Everest. In 2007, it was discovered that the glacier had been rapidly disappearing. Global warming is greatly affecting the volume of the ice and snow of Rumbug Glacier. The glacier shrunk 300 feet vertically, which is about the size of the Statue of Liberty in less than 80 years. Now here is how glaciers work. The forming of glaciers usually take about 100, maybe more than 100, maybe even thousands of years to complete. Now once the glacier is formed, winter and summer alternation will cause the water of the glacier to freeze and melt. This freezing and thawing causes the glacier to move forward, slowly of course, but with a lot of strength and energy. In winter, the accumulation of snow will also cause the whole glacier to move under its own weight. So you can see here, under the glacier, on the valley floor, there are debris and rocks. The alternation of winter and summer causes the glacier to move forward. Now this process is very slow, but at the end of a few years, we can really see the effect. We can now see that the debris and rocks have arrived at the end of the valley, and that is where the glacier deposits it's the rocks and all the debris it collected from the valley. The glacier acts as a sandpaper on the ground. In the case of the Rumba Glacier, here's how it moves. As it moves, it pulls the debris with it. This here is a glacier, and here are the debris and rocks on the surface. As it moves, you can see it carrying the debris down the valley with it. Now, glaciers don't solely scrape the surface of the land. They also break it. Water has tremendous force and strength when freezing. The force is so powerful that it can literally crack rocks into pieces. This is a zoomed-in cross-section of a glacier. Through the alternation of summer and winter, the ice in the cracks will melt and freeze. The water can expand up to 9% its original volume when frozen. The strength of the freezing ice will cause the rocks to crack like so, therefore freeing the rocks from the ground. The broken rocks will then be scraped away by the glacier. This is how the glacier breaks rocks and creates valleys. This process will take years, therefore making this process extremely slow. However, the true power of these slow-moving masses of ice can be seen after hundreds or thousands of years. Here are the Great Lakes. The glaciers of old have literally carved out more than 22,000 cubic kilometers of rocks and debris during the creation of these lakes. On average, swimming pools have approximately 51 cubic meters of water. The volume of rocks that has been moved aside to form the Great Lakes could be comparable to the volume of 2 trillion swimming pools. To sum this episode up, glaciers are very important for Mother Nature. Without them, most of our famous landmarks would have never existed. This episode is supported by Clean Air Task Force, which is a US-based NGO that fights air pollution since 1996. They are actively reducing carbon dioxide emission and are also placing regulations on diesel, methane, and shipping. You can help actively fight global warming by donating to this great organization. Thanks for watching Weathering and Erosion. Have a great day.